So we have this example for a projectile motion, and as I told you in that example in chapter 2 with the policeman and the car, it's a typical problem. Like you will find this kind of problem in any book talking about projectile motion. Let's read it together and then start solving. A stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial velocity of 20 meters per second as shown. The height from which the stone is thrown is 45 meters above the ground. So, first of all, it's a projectile problem. So, we have equations in the x, and we have equations in the y. So, we look for the distance in the x, v initial in the x, v final in the x, what is the acceleration in the x, and what is the time in the x. And also in the y, we look for the distance or displacement in the y, v initial in the y, v final in the y, acceleration in the y, and time in the y. So let's see the information he gave us. First of all, theta is equal 30 degree. When you see theta in a projectile motion, that means automatically, without he asking you to do so, automatically you analyze v to vx and vy right away, without thinking. So right away I write v node x, that is v cosine theta, and v node y, that's v sine theta. Put the numbers. V is 20 meter per second. So when I write v without a vector, that means that's the quantity of v, and I have the angle, so that's a vector. So 20 cosine 30 and 20 sine 30. So please give me the answer. Use your calculator. ما شاء الله يا مان جاهز. So Vx is 17.3 meter per second. And what's Vy? Vy is 10 meter per second. So that's automatically, without he asking anything. When you do projectile, you calculate the components. Fine. Now in a projectile motion, we have x component and we have y component. And in the y component, it's just a free fall. It is just a free fall. So I need to determine my reference point, and I need to determine where is positive, where is negative. So this example, exactly this example, we solved it in the free fall problem. So this is my y node is equal 0 here at this point. down negative, up positive, and always G is pointing down. So let's try to fill those information. V initial in the x-axis is 17.3 meter per second. V final in the x-axis Dawood, shukran ya Dawood, it's also 17.3 meter per second. Why is that? Because in the x projectile motion, in the x-axis, acceleration is 0. So this is 0. And let us see if he asks us to calculate D, but we will see. طيب. In the y, we know that the distance is minus 45 because this is our reference. Below our reference is negative. We said downwards negative. So our distance is minus 45. V initial 10 meter. And now you have to pay attention because it is plus 10 meter per second because it is pointing up. It is pointing up. V final, we need to calculate. What is G? What is G? Plus or negative? أيوة يا سلمان أحسنتوا. It's minus 9.8 meter per second square. And let us see if he asks us for the time. So let's see part 1. How long does it take the stone to reach the ground? So he is asking for the time. He is asking for the time. So we will solve it as if it's a problem in the free fall. As if it's a problem in the free fall. So what equation do you suggest to use? MashaAllah, I have one of your colleagues came to the office hour. Thank him very much. And he asked me that question, Doctor, how should I decide between all those equations of kinematics? And I told him, you look for an equation that only one unknown in it, and then you use that equation. So what do you think? What equation? Look at the 5 equations and tell me what equation we should use. So that is A. Well, how about this one? We know Y, we know Y node, we know V node, and we know the acceleration. So the unknown here is the time. So how about this? Okay. So now we have to be careful. We can use this also. We will see if it gives us the same value. داود صح يا داود لأنه it's V is equal V node plus AT. We know V node, but we don't know V final. So we cannot use this. بصير 2 unknowns. يعني your colleague just said, okay, let's use this equation, ya Ustad. We know this. This is unknown, and this is unknown. So we cannot use an equation with two unknowns. The equation you must use, it must have a one unknown. Right. Here, we need to be careful when we put the numbers. So y is minus 45, 0. V node y, this one, V node y, is it positive or negative? Ahmed, positive. V node is positive because it's pointing upward, and we said upward is positive. So plus 10t plus half. Now G is negative because it's pointing downward. So we end up with this equation, minus 4.9 t squared plus 10t. And then we bring this on the other side, plus 45 is equal to 0. After this equation, it's math. It's no more physics. So the physics is how to write this equation. So can somebody solve it for me and give me the two roots? So here, t is equal طيب, how about the other root, the second root? Two, and the other one is minus 2.18. This is a minus. So which one we should take? The minus or the positive? Of course the positive. Of course the positive. So this is our answer. So second. And of course he's solved the equation like we did. طيب. What is the speed of the stone just before it strikes the ground? The time is the same for both, of course, because once it touches the ground, either in the X or in the Y, that means the projectile motion is over. So if it touches the ground in the X or in the Y, that means projectile motion is over. For that we have the same time. طيب. الحين we'll find V node in the Y, and that's not the answer because we need to consider also the X component. So in the Y, we use V final is equal V initial plus 80. So what's V initial? What was V initial in the y-axis? It was plus 20 minus 9.8 multiplied by 4.22 second. And what's this answer? V initial was 10. Sorry. شكرا. مين هذا؟ داود؟ حمد؟ داود. شكرا يا حمد وداود. What's this answer? في اختلاف في وجهات النظر. Anybody can tell me? Okay, so the answer is minus 31.4 meter per second. And this is not the final answer, because he asked me what is the speed. The speed, and when it hits the ground, this is only, so this is the stone, so this is only the y final, but also don't forget that we have an x component. So our final speed is this vector. So now we know the x component of that vector, and we know the y component of that vector. So what's the value of that vector? Well, v final. So let me put here y. Well, it's understandable, but then vy, the initial y. So that is equal to, what's the value of vx squared? What was the value? 17.3 plus minus 31.4. And if you do the calculation, you will get 35.8 meter per second. But doctor, when the object hits the ground, surely it loses some of its speed in the x-axis? No, because in these kind of problems, by default, we ignore air resistance, we ignore motion of earth, we ignore if there is a wind or there is no wind. So all those things, it's a very simple problem. We just ignore all of that. As if we are moving in a vacuum, but just to make things easy. Because if you listen to a previous video, we said in projectile motion, if you need to have an accurate answer, you need to calculate, you need to consider Earth rotation. Because if your projectile from south to north or north to south, it will be different if you shoot it from east to west. V final is that blue vector. Asim asked, what is V final? Well, V final is the blue vector. Not final velocity, final speed. Final velocity, you need to find the angle. If you want to say final velocity, you need to find the angle, or we write it as a vector. So Dawood gave us a nice idea. Type final velocity as a vector is equal the x component, which is 17.3 I plus minus 31.4 J. That is meter per second. So that's the final velocity. That's the final velocity. What's the final speed? This is the final speed. Clear? طيب, let's do an extra one. Let's find theta. يلا, what is theta? We know that V final is equal Vx cosine theta. So that means cosine theta V final over Vx. V final is 35.8. Vx is 17.3. Oh, because cosine cannot be more than 1. So this is Vx and this is V final. We just switched them. Vx, V final, 17.3, 35.8. Yeah, what is theta? When you put those numbers on the calculator, you will get 61.1 degree. But that's above the x-axis. So you need to do theta. So let's give this a theta prime. So theta is equal 360 minus 61.1 degree, 298.8 degree, as your colleague Ahmed said. Always in physics you should put the calculation. Always in physics. Because if you do a mistake in the number, then the deduction will be small. Unless your mistake in the number is way out of proportion. يعني for example, we need to calculate V final. And instead of that's in the exam when you do written stuff, when you solve a problem by hand. So the answer is 35.8. Suppose you did a mistake and the answer was 34.1. So the deduction will be small. Why? Because I know that you did everything right. The final number is wrong. So deduction will be small. However, if you do a mistake here in the equation, like you don't know what numbers you put, then the whole thing is wrong. The whole thing is wrong. So if you show me your calculation for the angle, and then instead of 61 you have 60 or 59 or 58, well, the deduction will be small. But if you don't show me anything and the answer is wrong, everything is wrong. That's correct, yeah, Yusuf, because we know that the vector is in this quarter. So right away we subtract from 360, or we add 270. So we know it's in here. طيب. Now let's see this. He said, what if a horizontal wind is blowing in the same direction as the stone is thrown, because and it causes the stone to have a horizontal acceleration. So now it's no more projectile problem. Now we have acceleration in the x-axis. Which part of this example will change, A or B? Of course, time will not change, because time depends on how long the stone will stay in air, and that does not depend on the x component. However, in the because now we have acceleration in the x-axis, v final x will be a little more, and then v final will be also a little more. Range will change, that's correct. بس يا عبد الرحمن, be careful. When you calculate the range, we don't use those equations anymore. Never use this equation, because this equation is only you can use it in y is equal y naught is equal 0. So if you want to calculate the range in this problem, you don't use this equation. Be careful. طيب, now how do you do in this problem? Well, here's the range. We know the time now, correct? You multiply it by the x component. So we can add another one, range, اللي هو r, so we know the velocity, is 17.3, multiply it by 4.22 seconds, and it will give me my range. So what's this number, يا جماعة? So 73 meter. Now you know why it's one step, and he just took a very long time, a very long derivation just to reach this equation, and you cannot use this equation in any projectile problem. It's one line when you solve the problem correctly. You cannot use this equation to calculate the range, unless y is equal y naught is equal 0. Be careful. طيب, now we come to a concept that is sometimes confusing for some people. It is the centripetal acceleration. When you go into a uniform circular motion, you will create a centripetal acceleration. Centripetal acceleration. And of course, acceleration is delta V over delta T. Take the limit, it will be just the derivative of the function of velocity. Now here is the confusing part. What's the confusing part? When you go, suppose that you are riding your car and you go in one of the roundabouts that is left in Qatar, let's say a roundabout in the university. When you go into a roundabout motion, where do you feel the force? Towards the center or away from the center? No, my question, I didn't ask where is the force is pointing. My question is, what do you feel? Tai, I will ask you, some of you are shy, I think. Tai, I will ask you this. When you ride your car and you are at the traffic stop, the traffic sign is red, you stop, correct? And then when it is green and you start to accelerate harsh in your car, where do you feel your body goes? You don't drive. Okay, when somebody is driving with you, there is no away, Ahmed. Just the car is moving forward. Where do you feel the force? Speed is 0. No, we start moving with acceleration. We start moving with acceleration. Where do you feel the force acting on you? So this is the car. And now you start to accelerate, so this is acceleration. Where do you feel the force? Where your body move. Yeah, you feel that the force, your body is moving backward. Tai. Now you are driving in your car and you press the brakes. That's your car. And now press the brakes. So that's acceleration. Where do you feel you want to go? You hit the airbag, la samahallah. So in both situations, you feel that your body want to go against the force because of inertia. Because of inertia. And we took that in chapter 2 when we said everybody has inertia. It will work against the motion. If you are moving and want to stop, your body wants to continue. If you are stationary and you want to move, your body wants to resist the motion. That's inertia. That's inertia. And in both situations, what you feel is against the force. Convinced? Okay. In the centripetal motion, here is the acceleration. So you feel when you go into a roundabout, you feel that you want to go away from the center. Why? Because centripetal acceleration is pointing to the center. Convinced? This is why you feel when you go into a roundabout, this is why you feel that you want to go away from the center. No, force is always in the direction, same direction of the acceleration. I am talking about the inertia, what you feel. What you feel when you have a force is that you move against, if you can, you move against the force. But force and acceleration, that's Newton's second law, have the same direction. Yaman said that this is why humans need physical training because of the height. Well, they need physical training because they have playing with a jet will create enormous acceleration. And that acceleration will affect on the body. Most of the time, it will prevent blood to go to your brain. So you faint. This is why they have special clothing and they go into extensive training. Because the acceleration is huge when they start playing with the jet. Dawood said if you speed up in a roundabout, you need to steer more. That is correct, but if you speed more and more, you will reach a point where the car will flip. The car will flip because of something we will study, inshallah, in the coming chapters. The torque, due to the centripetal force, you will create a torque on the car. And if you go fast enough, that torque can flip the car. Not all cars are drift, because also this is a second thing we are going to discuss, inshallah. Friction. There is static friction and there is kinetic friction. And the car between the wheels and the road, always you have static friction, which is larger than kinetic friction. So you cannot force the car to go into kinetic friction to do a drift. You cannot do that with normal cars. You have to have a special wheels and special environment. Yani the road has to be slippery or sandy or something like that. Then you start to drift. And when you drift, you avoid flipping. عادل, you need horse power حبيبي. فعلا horse power لأنه at normal speeds, normal cars, normal wheels, always you have static friction. Drifting, that means you enter into the kinetic friction, which is less than the static friction. But in order to enter in that region, either you should have sand or water or more horsepower or whatever. Anyway, we'll cover that all, inshallah. I have a feeling that some of you is drifting. طيب. Now, here is the proof why centripetal acceleration is pointing to the center. Remember this? When we spend about 10 minutes to calculate delta R? Previous lecture. So R initial, R final, so this is delta R. This is V1 or V initial, V2, and this is delta V. And this is delta V. And if you draw a circle, here a circle, continue, not this one. We draw a circle. You see that this is V1 and this is V2. And where's the acceleration? The acceleration is pointing to the center. So this it will give me A is equal delta V over delta T. This is a vector and this is a vector. And the direction of it, so we are moving here at the top of this circular motion. And where is the acceleration? It is pointing towards the center. It is pointing towards the center. So the acceleration as a vector has a magnitude and a direction. What's the magnitude of the centripetal acceleration? It is v square, the magnitude of velocity square, divided by r. Divided by r. So r is the distance from the center of the circle to the edge. R is the radius. So, where is the direction of the centripetal acceleration? Away from the center or towards the center? The centripetal acceleration direction is towards the center. What is the proof? Well, acceleration towards the center, I want to run away from that acceleration, so I go in the opposite direction. It's like when I brake, acceleration backward, I go forward. When I accelerate in my car, acceleration is forward, I go backward. So always we feel the motion opposing the centripetal acceleration. No, V is constant. V is constant. Let me remind you, V1 does not equal V final, but the magnitude are equal. Speed is constant. Velocity is changing. It's not a linear acceleration, it's centripetal acceleration. For that we put AC, centripetal. This is centripetal. It's written here. It's not linear acceleration. In this situation, linear acceleration is equal 0. Linear acceleration is equal 0. We can write it also. هلا احمد مين احمد ولا مين راح يمان يمان بيقول I'm not fully convinced because if you let an object flies in the direction of the vector velocity, yeah, it will continue it will continue to go in a straight line. But for centripetal acceleration, you must have something that will hold the object to go into that centripetal motion. And that thing, if it is a string, or if it is gravity, like what is holding the moon to go into a centripetal acceleration with Earth, it's gravity. There must be something holding that object, forcing that object to go into centripetal motion. Either friction, like a car on a road, or a string holding the object, or gravity holding the object. There must be some kind of force forcing the object to go into centripetal motion. Now, when it goes into centripetal motion, you will have centripetal acceleration pointing towards the center. If you cut the string or remove gravity or remove friction, the object will move in a straight line. The object will move in a straight line. So for any centripetal motion, you need something that will force the object to go into circular motion. So in this case, velocity is changing, speed is constant, linear acceleration is 0, and we have centripetal acceleration only. If the case of gravity, centripetal force on Earth would be the gravity of the sun. Right, yes. That's correct. And that's why the moon also stay orbiting around Earth, because the gravity is forcing the moon to go into centripetal motion around Earth, and Earth around the sun. That's correct. If there is no gravity, the moon will just shoot in a straight line, and Earth will shoot in a straight line. That would be fun. Well, if we stay away from the sun, Earth will freeze in no time. طيب straight to Jannah إن شاء الله يعني. But the wisdom of Allah subhanahu wa ta'ala is to keep Earth going around the sun, to keep life. طيب. We said here that A centripetal is equal V square over R. لاحظوا هون, this is magnitude. What is the direction? Towards the center. Towards the center. هلا, he wants here to play with some equations. Why? Because it's an introduction for our circular motion in the future, in the coming future, inshallah. But let me tell you something much easier than this. What is the radius? What is the radius? What is the circumference of a circle? It is 2 pi r. We start like this. طيب, what is 2 pi? It's an angle. So that means D is equal theta r. V is equal omega r. A is equal alpha r. You see the relation? So we start with the circumference of a circle? Well, it is a distance. This is meter, this is radian, and this is meter. Well, it can be written as theta r because 2 pi is a theta. Same relation with speed or velocity and angular velocity, and acceleration and angular acceleration. That's the relation. So if you are confused, personally, always I'm confused. Is it, do I multiply by theta with d or with r? So whenever I'm using angular motion, I'll just start with this simple line, and then I find the relation is linear relation is theta multiplied by r. Linear velocity is omega multiplied by r. Linear acceleration is alpha multiplied by r. So here he used this relation and he substitute v here. So we end up with acceleration is equal omega square r square over r. So omega square r, this one.
دكتور بس ممكن ترفع تاني الايكويشنز اللي فوق.
هاي تفضل.
مش الاكسلريشن المفروض تكون WR/T؟
WR/T.
يب الاكسلريشن از ايكوال تو velocity/T. ليه دلوقتي احنا عملنا W سكوير؟
لأنه هاي centripetal، هاي مش linear. Those equations apply only for circular motion مش linear motion. Those apply for circular motion. Linear motion لا، الكاينماتكس. ومش بس circular motion، uniform. يعني الماجنتيود is constant تبع الفيلوسيتي، والريت اوف تشينج
طب
برضه constant. هاي نحط لها عشان نزيل هذا، هاي centripetal، هاي centripetal. تفضل.
بس كنت بسأل الثيتا والدبليو والألفا
هدول حنحكي عنهم. هو ما دام انه فتح الباب على الاوميجا، عرفت؟ فاحنا بنحكي لكم انه ان شاء الله لما يجي الشابتر حنحكي عن الثيتا اللي هي الانجولار ديسبيسمنت، اوميجا اللي هي انجولار فيلوسيتي، والفا اللي هي angular acceleration in a circular motion. That's not linear motion, that's a circular motion. In a linear motion, we just use our kinematic equations if acceleration is constant. This one, how did I get this one? I last equation. This one? Okay, well, we know that V is equal omega r, and centripetal acceleration is equal V square over r, so we just substitute. طيب, the last slide in this lecture. Now we will have two accelerations. we will have two acceleration. Radial acceleration, the one we just talking about and explaining, and we have the old acceleration اللي هي linear acceleration أو tangential acceleration. So now we have two accelerations. This is the centripetal acceleration that we just introduced, and this is the tangential acceleration that we use kinematics to calculate. So we have a vector. Has two components. The first component is this one, and the second component is this one, and the magnitude of the new vector is this one. Let me just, so we can see. So the magnitude of that vector is the centripetal acceleration square plus the tangential acceleration square. So in this situation, suppose that we are not in a uniform circular motion. That means the object from point 1 to point 2 will go into so this is V1, this is V2. In this situation, V1 does not equal V2. That means even the magnitude of the velocity, is changing. So we will have a tangential acceleration as if it's moving in a straight line plus the centripetal acceleration. And the result is a vector. Sum of two vectors, tangential and the radial. The magnitude of that vector is the magnitude of the first vector square plus the magnitude of the second vector square, and the direction is also the direction we can calculate from the component of the two vectors. Radial acts as y and tangential acts as x. That is correct because well, it depends if it is going in a perfect circle or if it's going in a different circle. It's not always, the angle is not always 90 degrees between the two components. Yaman said, how is the magnitude changing? Isn't the linear acceleration zero? Yes, the linear acceleration is zero in here, in a uniform circular motion. Now we assume that you understood uniform circular motion, and then we add to what you understand already, we add something else, and now we assume that we have a linear acceleration plus the circular acceleration. And then the result will be adding two vectors. Yes, acceleration, change direction and change velocity. While velocity also change speed, because velocity is always changing in uniform circular motion. But here, to have a linear acceleration, you need the speed to be changing. If the speed is constant and only direction is changing, then you have centripetal acceleration or circular acceleration. No, they are independent. Yaman said the tangential acceleration is changing the velocity magnitude. No, they are independent of each other. But suppose in a situation that you have a circular motion, and while going in a circle you start to accelerate linearly, then your acceleration will be the sum of both accelerations. Doctor, can you include the formula sheet that will be given on Blackboard? So formula sheet, why I have to put a formula sheet in Blackboard? Everything is open book. A quiz or a homework, it's an open book. In the exam, I will include all the equations in the exam sheet. Sure, in the exam, I will all the equations that you need, I will consider. I'll put them in the exam sheet. But for the quiz and the homework, it's an open book. You can open your book and read whatever
Yes,
equation.
but the thing is, like we have to look through all the notes and.
That's correct.
And
This
just
is
select
this
all
is
the
why.
equations together.
That's correct. This is why, when you study, you prepare your own notes, and then you will have your own sheet, depending on your study, and you write for each equation. You write some notes like be careful to do that. Be careful not to do that. And pay attention for the sign. Something like this. Well, radial acceleration and centripetal acceleration are the same. You have centripetal acceleration, radial acceleration, and you have linear acceleration. So centripetal, that's going towards the center because of going into a circular motion, and linear because you are changing the speed. Tangential acceleration is the linear acceleration because we are moving at the edge of the circle. So that's why we call it tangential acceleration. It's the linear acceleration. يا تفضل يا أحمد.
دكتور أنا عندي سؤال على اللي فوق. يوم طلعنا الدي إيش كانت وظيفتها في المعادلة اللي طلعتها آخر شيء؟
الدي اللي هو المحيط، محيط الدائرة.
دي وين استخدمناه طيب؟
ما استخدمناه احنا ما استخدمناه بس لأنه الكاتب دخل الأوميجا في الموضوع. الأوميجا اللي هي الانجلر فيلوسيتي. فأنا علشان أزيل الغموض تبع الانجلر فيلوسيتي قلت لكم شو الريليشن بين اللينير والانجلر.
تمام.
عرفت؟ الدي هاي لينير اللي هو السيركمفرنس. طيب شو العلاقة مع الثيتا؟ بنضربها في ار. نضرب الثيتا في ار بعطينا السيركمفرنس. اللينير فيلوسيتي شو علاقتها بالاوميجا؟ نضربها في ار. واللينير اكس ما دام صرنا حاكيين عن الثنتين نحكي على الثالثه اللي هي اللينير اكسلريشن، عفوا سنتريبيتال اكسلريشن مع الالفا اللي هو الانجولار اكسلريشن.
تمام.
يعني كيف بدي اقنعكم انه سنتريبيتال اكسلريشن ايكوال ار اوميجا، ولا هو حاكي عن ما درسنا الاوميجا الانجولار فيلوسيتي ابدا. فاضطريت انه اجيب لكم اياها هيك، لانه حنغطي ان شاء الله الانجولار سبيد وانجولار فيلوسيتي وانجولار ديسبيسمنت، حنغطيها ان شاء الله. but not now. هلا يعني جلمس، هلا بعطيكم جلمس. Any more questions? طيب, let me stop the recording. Can we solve examples regarding these equations? Well, unfortunately, there is no time to do any examples. You just go to the book and solve the examples in the book. لأنه we cannot do exams at all. يعني we barely can cover the material. Well, this is the situation for all physics 1. يعني you go to any university, this is how they teach, because you need to cover a lot of material. Most of the effort will be on the student. So as we told at the beginning, it's 3-hour teaching and you need 9 hours studying every week. 9 hours studying every week. So let me stop the recording.